Okay, I'd like to welcome you all to the hardware management track. This afternoon's session will be focused on hardware fault management, and then later this afternoon it will be on the hardware management module, also known as Run BMC or DCSCM. So we're going to start with hardware fault management with an overview, a couple presentations, and then a panel.
All right. Thanks, John. Hi, everyone. I'm Yogesh Varma from Intel. I'm one of the leads for this subproject. And on stage with me is Drew Walton, is a fault management lead from Google. Today we're going to provide a status update about what we have been doing and we do in this subproject and the future direction, what we want to do. So we are an incubation subproject of hardware management project. And our goal is to improve hardware fault management at scale because we are represented by a lot of CSP and hyperscaler fleet community, and we all agree that as the data centers and fleets are becoming heterogeneous and larger at scale, there's a dire need to improve our existing methods so they scale across the different usage model and heterogeneity. Our subproject meets every week, and we are very well attended by several industry stakeholders, as you can see. We have all sorts of silicon vendors, OEMs, and hyperscalers in our group, which attend, and all the memory vendors as well, which attend every week, and we are working on this requirements document to create a framework which solves all these problems. So our vision is to create an industry standards-based vendor and silicon agnostic fault management infrastructure framework. Now that was a mouthful, but basically we want to create a framework which is vendor and silicon agnostic and is extensible, that can be extended to current and future heterogeneous fleet and different hyperscaler use models, right? And our approach is we spend a lot of time in last year identifying the pain points, right? What are the problems? So we have folks from Meta here, from Google, from Microsoft, and even OEMs. They all got together, made a list of things that we have to deal with and how we represent the errors, what's the formats and all that. The next step, we started working on what should a hardware fault management infrastructure look like. So we are working on a framework requirements document, which will be contributed to OCP soon. And further, as we define this framework, we will need to work with the various stakeholders to define the brains for it, the software, the code, various analyzers from different silicon vendors and memory vendors, right? And finally, to make it all work, we will also need to work with industry standards bodies like Redfish, ACPI, OpenBMC to make amendments to their existing standards, right? And with that, I'll hand it over to Drew.
Okay, I'm excited to be here. The work that we're doing just has so much potential, and I also get to work with some of my favorite people. It's kind of like a reunion because this is a small community. And as we get back together, we find that we still, after all these years, have the same problems we had a few years ago, and we're at a point where we can actually do something about it. So we're defining this framework that will create interfaces that allow me to get error data from a processor and drive RAS actions on it, whether it comes from AMD, Intel, or an ARM vendor. We're going to define this so that we can get error logs out of band, supporting bare metal machines, and we're integrating that into OpenBMC. So there'll be a reference implementation. We can plug code into OpenBMC and get very detailed information from the system without having to rewrite a whole lot of code. The vendor that created the silicon provides the frame or the software in our framework to get the data that we need. And then we can drive OS actions. So if we want to do something, a post-package repair or retire a page, or if there's something special like a partial cache line spearing feature, we can drive that from these out-of-band interfaces. That's particularly exciting to me as someone who's driven these things in the past, because the investment required to create software to even test this has been cost prohibitive. It's required a level of expertise that a typical server user doesn't have. If we can create these interfaces that are easy to use and easy to check out, we lower the barrier to entry. We make it easy to try new features. We also are developing a schema for integrating various analyzers. This is also one of the things that I'm tremendously excited about, and here's why. Today, I bet most of you count your memory errors. You count the number of flipped bits you had and you decide whether a part's bad. Well, let me tell you from experience that you would probably be better off just flipping a coin when you saw a memory error. So, and if you go to any of the memory vendors, when they're here today, they will tell you that it is tragically wrong. But how do you develop the expertise required to figure that out? Do you understand how the failure modes in a DRAM map to a particular processor's ECC? That requires a level of expertise that is nearly impossible for the typical fault management person to gather. So I'm particularly excited, and we'll show this today in one of our future presentations, on ways we're considering enabling memory vendors to take error data from the machine and give us additional data about what's happening in it. And we want to extend this to other areas like NICs, smart NICs, GPUs, other accelerators. So we have some sessions today. We hope that you'll attend. Well, the first one is a hyperscaler system error reporting introduction. And Minfeng is going to show us it's really a proof of concept. ByteDance has done some really exciting work to gather error data and show that they can analyze things at scale. So this is a proof of concept that shows that we can do some of the things we're talking about doing. After that, I'm particularly excited about this one because I'm presenting something with Intel and AMD. And we're going to show you our proposal, and we'll walk through what it looks like and how we plan to integrate things. And then after that, please stick around. We have a panel where we have a whole bunch of experts in this area to answer questions that Vilas will pose to us. We're eager to talk to you about that, and of course, we would love it if you join us. We have a call to action. We meet on Fridays. Please reach out to us. We would love to talk to you. We'd love to grow the group and get your input and make sure that the things that we're doing also solve your problems. We believe that if we can find ways to enable collaboration with the vendors, that we can drive quality improvements that help all of us. And we all want reliable systems. I would prefer to be innovating in other areas. And so if we can solve these problems together, we can then focus our innovation in areas that are new and exciting and don't require us to fix something that we already wish was working. So I think with that, anything else?
We are good on time. I guess if we want to take any questions.
Oh, you have about 2 minutes, so if there are any questions.
Yeah, any questions for us before we get started on the other sessions?
You said your goal was to be hardware agnostic. Could you say a few words about that?
Well, so the framework doesn't care what processor or what card it's getting error data from, right? And so the vendors care. So if I have an AMD CPU, then I will have an AMD connection into the infrastructure. And we'll go into the details of what that looks like. But when I say give me your error data, I should be able to get that, whether it's an AMD GPU or an Intel processor. It shouldn't matter. I should say, give me your error data. And then we'll pass that up to an analysis tool that makes sense of that data somewhere higher up in the infrastructure. And we'll have the details of that a little later.
I understand, but I guess that each one of the vendors has specific IPs that relate to fault management and telemetry and stuff like that. So how would you be able to
I can,
We'll talk about that.
I can tell this is going to
Yeah,
be.
I'm sorry. We have a whole presentation on that, so please stick around.
In the interest of time, and given that it's time for the next presentation, and given that all these discussions are going to be held with in the panel, I would like to hold your question until the panel discussion, and then we can allocate the time. But thank you, guys.
Okay, sorry. Yeah, thank you.